Hello everyone! Welcome to our math lesson on logarithms. I'm your online teacher, and today we're going to work through some interesting problems together. I know logarithms can look a little intimidating at first, but here's the good news. Once we break them down into simple steps, they become much easier to understand. Let me start with a basic question. What is a logarithm really? Think of it as asking the reverse of an exponent question. With exponents, we ask, what do I get when I raise this number to this power? With logarithms, we ask, to what power must I raise this base to get this number? For example, if I say log base 10 of 100 equals 2, I'm really saying 10 raised to what power gives 100? The answer is 2, because 10 squared equals 100. Today, we'll solve 3 logarithm problems. Each one will teach us something important, and we'll work through each in exactly 8 steps. I'll explain each calculation as we go, and I want you to think along with me. Ready to begin? Let's start with our first problem and see how we approach it systematically. Problem 1. Log base 10 of x equals 2.5. 8 steps. Step 1. Our first problem, log base 10 of x equals 2.5. We need to solve for x. Looking at this, where should we start? Step 2. We use the fundamental definition. Log base a of b equals c means a to the c power equals b. Always start by converting to exponential form. Step 3. Applying this rule gives us 10 to the 2.5 power equals x. So we write 10 to the 2.5 equals x. Now we need to calculate 10 to the 2.5. Step 4. Notice the 2.5 is 5 divided by 2. So we can rewrite 10 to the 5 over 2 equals x. A fractional exponent combines power and root. Step 5. 10 to the 5 halves means the square root of 10 to the 5th power. Let's calculate 10 to the 5th. 10 times 10 equals 100, times 10 equals 1,000, times 10 equals 10,000, times 10 equals 100,000. Step 6. Now we need root of 100,000. Let's simplify. Root 100,000 equals root 100 times root 1,000 equals 10 times root 1,000. Step 7. Simplify root 1,000. Root 1,000 equals root 100 times root 10 equals 10 times root 10. So we have 10 times 10 root 10 equals 100 root 10. Step 8. Therefore, x equals 100 root 10. For a decimal, root 10 approximately 3.1623, so 100 times 3.1623 approximately 316.23. Our answer, x equals 100 root 10 exactly, or x approximately 316.23. Problem 2. Log base 3 of x minus 1 equals 2. 8 steps. Step 1. Problem 2. Log base 3 of x minus 1 equals 2. Same approach. Convert to exponential form using our definition rule. Step 2. The rule says log base a of b equals c becomes a to the c power equals b. So 3 squared equals x minus 1. That gives us 3 squared equals x minus 1. Now calculate 3 squared. 3 times 3 equals 9. So we have 9 equals x minus 1. Now we need to solve for x. Step 4. Add 1 to both sides. X equals 9 plus 1 equals 10. So we get x equals 10. But wait, we're not finished yet. Step 5. We must verify our solution. Plug x equals 10 back in. Log base 3 of 10 minus 1 equals log base 3 of 9. Step 6. Now check. 3 raised to what power gives 9? 3 squared equals 9. Yes, so log base 3 of 9 equals 2. Step 7. Critical domain check. The argument x minus 1 must be positive. For x equals 10, 10 minus 1 equals 9, which is greater than 0. Good. Since the solution satisfies both the equation and domain requirements, our final answer is x equals 10. Problem 3. Log base 10 of x plus 2 plus log base 10 of x minus 1 equals 1. 8 steps. Step 1. Final problem, log base 10 of x plus 2 plus log base 10 of x minus 1 equals 1. Here we have two logarithms being added. Step 2. We use the product rule. Log a plus log b equals log of a times b. Combine them. Log base 10 of x plus 2 times x minus 1 equals 1. Step 3. Now apply the definition rule. Log base 10 of something equals 1 means that something equals 10 to the first power, which is 10. So x plus 2 times x minus 1 equals 10. Expand using FOIL. X squared minus x plus 2x minus 2 equals x squared plus x minus 2. So x squared plus x minus 2 equals 10. Step 5. Bring all terms to one side. X squared plus x minus 2 minus 10 equals 0, which simplifies to x squared plus x minus 12 equals 0. Step 6. Factor the quadratic. We need two numbers that multiply to negative 12 and add to positive 1. Those numbers are 4 and negative 3. So x plus 4 times x minus 3 equals 0. Step 7. Set each factor to 0. X plus 4 equals 0 gives x equals negative 4, and x minus 3 equals 0 gives x equals 3. Two potential solutions. Step 8. Domain check. Both x plus 2 and x minus 1 must be positive. For x equals negative 4 plus 2 equals negative 2. Invalid. For x equals 3 plus 2 equals 5, and 3 minus 1 equals 2. Both valid. Final answer, x equals 3. Types of logarithm rules. Rule number 1. Definition rule. This is the foundation. Log base a of b equals c means exactly the same as a to the c power equals b. This is how we convert between logarithmic and exponential forms. Rule number 2. Product rule. When adding logarithms with the same base, log a of m plus log a of n equals log a of m times n. We used this in problem 3 to combine two logarithms. Rule number 3. Quotient rule. When subtracting logarithms, log a of m minus log a of n equals log a of m divided by n. This helps simplify logarithms of fractions or divisions. Rule number 4. Power rule. When you have an exponent inside a logarithm, log a of m to the p equals p times log a of m. This lets you bring exponents to the front as coefficients. Rule number 5. Change of base formula. Need to convert between different bases? Use log a of b equals log c of b divided by log c of a. This works for any positive base c. Rule number 6. Domain restrictions. The most important rule to remember. You can only take logarithms of positive numbers. The argument must be greater than 0. Rule number 7. Special values. Remember these. Log a of a equals 1 because a to the first power equals a, and log a of 1 equals 0 because a to the 0 power equals 1. These come directly from the definition. Rule number 8. Identity rule. If log a of m equals log a of n, then m equals n, as long as both m and n are positive. This helps solve equations with equal logarithms. Our recap. Great work today. We've solved 3 different logarithm problems using a systematic, step-by-step approach. Let's review our process. First, identify the type of logarithm problem. Second, apply the appropriate rules. Third, always check domain restrictions. Remember that logarithms have real-world applications everywhere. They help measure earthquake intensity on the Richter scale, sound with decibels, and compound interest in finance. The key to mastering logarithms is practice. Try similar problems on your own, following the same approach we used today. If you get stuck, always return to the basic definition. Log base A of b asks A to what power gives b. This is the heart of logarithms. Thank you for learning with me. If you have questions, ask in the comments. Keep practicing and you'll master logarithms in no time. Help us grow this education channel, subscribe, hit the like and notification bell icon.